Welcome to the Everything Building Envelope podcast. On this show, we discuss topics relating to the exterior building envelope, such as waterproofing, glazing, cladding, roofing, and more. You can subscribe to this podcast on iTunes and Stitcher. For previous episodes, show notes, and bonus video content, check out our website, everythingbuildingenvelope.com. Now, here's your host for the Everything Building Envelope podcast, Paul Beers.
Welcome back, everyone, to the Everything Building Envelope podcast. This is Paul Beers. I want to remind everybody, first of all, before we get into today's topic, that we have a newsletter, the Everything Building Envelope newsletter, and if you would like to subscribe to it, please text the word building envelope to 22828. So it has technical articles and other things of interest to the building envelope community. Again, for the Everything Building Envelope newsletter, text building envelope to 22828. And I'm really excited about our guest today, Tom Madigan. Tom is an attorney. He's the chairman of the construction practice group at Buchanan, Ingersoll, and Rooney. Buchanan is a national law firm and has 6 offices in Florida, among other locations throughout the U.S. Welcome, Tom.
Thank you, Paul.
So Tom and I have worked together in the past. Of course, he's the lawyer and I was the expert, and we're old friends in that regard. And he's a great guy, and I think it's going to be really a very interesting podcast for everybody. So Tom, before we get going, maybe you could tell the listeners a little bit about yourself.
Sure. I'm a construction lawyer. I've been practicing 30 years now. I am a litigator handling both the prosecution and defensive claims, many of which involve building envelope performance, as well as delay claims and other performance disputes arising from construction of high-rise residential, commercial, and industrial across the United States. Done a lot of work in the southeastern United States on issues of water intrusion. I've done work in the northern United States on water intrusion and air intrusion and energy performance. And my work as a litigator has also given me a perspective on how to avoid some of the problems that I've seen. And I also advise clients on the front end in terms of contract negotiations, and then during projects to try to avoid disputes or mitigate them once they arise and keep them from turning into full-blown litigation.
So I think that that's really a great word, avoid. I know that that's probably what the listeners are most interested in, is not being involved in a long, energy-sapping, expensive dispute, but rather do what needs to be done up front to try to stay out of it.
Yes, I think that's everybody's goal, with perhaps the sole exception of the lawyers handling the litigation.
And maybe the experts.
And maybe the experts.
So we're talking about risk and risk management, and today we're going to talk about effective allocation and management of performance risk in the building envelope and construction. And Tom, would you agree with me that you talked about, you've done a lot of work in buildings with building envelopes, water leakage, air infiltration, things like that. Does the building envelope represent a disproportionate amount of claims on buildings?
It does, in the respect that when you have a building that doesn't perform properly and it leads to litigation, even when it's not exclusively related to the building envelope seems to be involved. So, whenever there's water intrusion problem with a building, you can almost guarantee that the building envelope designer, supplier, installer of all the materials and systems will be named, along with the roof and some other elements. Doesn't always turn out that the envelope was the source of the water intrusion, but those parties always get dragged in.
Yeah, occasionally I do seminars, speaking gigs and things like that. And one of my favorite lines starting out is that, what's the easiest way to screw up a good construction project? And it's have water leaking in at the end of the job. All hell breaks loose usually when that happens.
Well, and I think that, the building envelope, and some exceptions, it's typically a combination of various materials and systems, and that brings with it integration and coordination challenges, which, if not designed correctly, not installed correctly, create performance problems. So I think it's also a product of the complexity of the envelope of the building.
Well said. So let me ask you, what's the difference between risk management and risk allocation?
Sure. So risk management involves those things that I think everybody is typically familiar with and hopefully includes in their business organization. Quality assurance and quality control measures, supervision, inspection, testing, all the things we do to make sure that the work is of good quality and doesn't have deficiencies, or to catch them and correct them. And then on the far end, it involves insurance, for example, to manage the financial loss if the risk comes to fruition.
And then, so that's risk management. So what would risk allocation be?
Risk allocation is simply, and here we're talking about contractual, it's the assignment of responsibility for a particular risk. Which party contractually will be responsible for making sure that a particular element of the building performs in accordance with the needs of the owner and is liable if the end result does not meet that performance requirement.
So is this, for example, say that there's water leaking into a building and there's a litigation and everybody that's involved, the exterior of the building is named as a party, let's just say stucco, waterproofer, window manufacturer, and others. Is it the window manufacturer saying, look, my windows were perfectly fine, and even though the water is coming in near them, it's not my fault?
Now that's what I'd call, after the fact assessment of responsibility. What we're talking about with risk allocation is on the front end of the project, when the team is being assembled and the work responsibilities are dividing up through the contracts, which of the various trade contractors and suppliers and design professionals are going to be responsible for which elements. So for example, use your example, where you've got a building envelope that involves both EIFS and window systems. Contractually, who is responsible for making sure that the window system integrates properly with the EIFS so that you don't have a source of water intrusion at that junction? And if you do, who is called on to make it right?
So I think we all understand why risk management is important, but why is risk allocation so important?
Because who you allocate the risk to plays a big part as to whether it's effectively managed at the end of the day. The goal of risk allocation is to place responsibility with the right party. That is the party who's in the best position to manage or mitigate the risk or avoid it entirely, because that increases the chances of successful risk management. If the other goal is to place liability with the person who's best able to avoid the risk, because that's simply equitable, and then to place it on the party who's in the best position to absorb it directly, to make it right, or to carry the financial burden of its failure performance. If you allocate the risk to a party who's not in a position to effectively avoid or mitigate it, or who can't bear the cost of the risk if the performance fails, that just increases the probability that the risk is going to come to fruition and it's not going to be adequately remedied, and you're going to, for example, end up in a multi-party litigation with everybody pointing fingers at each other.
But isn't the thought that the designer is always responsible for design and the contractor is always responsible for construction?
So in very broad general terms, that's true. That relates to the traditional design build process, particularly in competitively bid public projects. But that's only a general proposition. It's not an absolute rule. Even in design build projects where you have an architect separately contracted to the owner and a GC under a different contract, the responsibility can differ depending on whether you have design specifications or performance specifications. Design specifications are where the plans and specs tell the contractor exactly what to build, what materials, what products to use, akin to a blueprint or a roadmap. Contractor in that circumstance's responsibility is to build in conformity with the design. If the construction conforms with the design, but it doesn't perform as the owner intended or needed, that's not the contractor's responsibility. Performance specifications, on the other hand, simply set a performance requirement that the contractor must meet. But the contractor has discretion on how to best meet that requirement. He has some discretion in the choice of materials, perhaps, and the choice of systems, certainly in the approach of construction, but he then bears the responsibility of those choices. And if he doesn't meet the performance requirements at the end of the day, it's the contract. And, frankly, most private projects are a combination of both, and it's sometimes not clear whether the specifications are design specs or performance specs, whether the responsibility lies entirely with the designer, whether it's been delegated in some respects to the contractor, exactly how much detail with respect to design is required of the contractor in the shop drawings and coordination drawings and submittals. Those things aren't always clear, and they're often the subject of litigation when things go wrong.
We see a lot of that at GCI Consultants on the construction projects we're involved with. When a contractor takes on design responsibility or risk, how do they allocate that at that point?
Could you repeat that question?
When a contractor takes on design responsibility, how do they allocate their risk?
So the first key there is for the contractor to understand that it's taking on a design responsibility and to knowingly assume that responsibility. If the building envelope component of the project is design build and the contractor's got the resources and the expertise to take on the responsibility, that's great. The biggest problem I see is where the contractor doesn't understand how much design responsibility it's taking on. You get those disputes over what the purpose of the shop drawings are. The architect is expecting the contractor to provide a lot of missing design detail, to show how systems will be integrated, to show details on joinery, to show details on integration both of different systems and with the surrounding conditions. But the contractor doesn't understand that's what's expected of him. He thinks he's just providing shop drawings that show, product details, and he's not prepared to take on the larger design responsibilities. That's the first key, is understand the risk that you're assuming and make sure that you're prepared to manage it and perform as required. The other element that comes up there often is a contractor may take on design responsibilities with the expectation that he's going to rely on a subcontractor or a supplier. He's not actually going to do the integration details, do the design details. That he'll rely most commonly on the system manufacturer, but won't be clear in his or her dealings with the system supplier, so that the system supplier doesn't understand what's being required of it. It doesn't commit the right personnel or attention to the application engineering and coordination, or the contract between the trade contractor and the supplier don't reflect the allocation of design responsibility to the manufacturer because it's a standard form contract of sale that says we're just a supplier, we just supply the materials in accordance with your takeoff. Application engineering is excluded. Shop drawing preparation is excluded. So the contractor's taken on the risk, isn't in a position to perform, and then hasn't effectively allocated the risk downstream to the party that it's relying on.
Yeah, because if you have a scenario where, let's say that the design is vague, maybe intentionally vague with regards to certain systems, and the contractor passes it on to a supplier or sub or whatever without really adequately covering all the bases, shop drawings, submittals, things like that. They're effectively, correct me if I'm wrong, they're effectively letting the subcontractor ultimately design it and probably not properly allocating the risk.
Right. What happens is a couple of things. Because when something goes wrong, you know how this works, it flows downhill, right?
Yep.
So if the building envelope doesn't perform, the owner looks to the GC and the architect, because the first question is it a design problem or a construction problem? In your hypothetical, the architect says, well, I allocated design responsibility to the contractor. General contractor then turns around and says, okay, Mr. Glazing subcontractor, I allocated responsibility to you. I don't care if it's an installation problem, if it's a design problem, if it's a product problem, because you're responsible to me for all of those things. Subcontractor then wants to, if it's a product problem or if he was relying on the manufacturer to do the design details and coordination, subcontractor wants to now look to the manufacturer to offload that liability. Problem is, the manufacturer says, well, but our contract doesn't allocate that liability to me. I say I'm not responsible for those things. So it doesn't matter that you might be responsible to the general contractor. I'm not responsible to you. I disclaim those things contractually. The liability stops with you. Even though subcontractor may not have done that work, may have been relying on the manufacturer to do it, because the contracts didn't line up with the actual allocation of liability, subcontractor finds itself holding the bag.
And hence the dispute.
Yep.
So what are some of the performance risks that need to be allocated between the architect and the contractor with respect to design of the building envelope?
So we just touched on a lot of them in that example, but it's things like starting with determining what the performance requirements are for the building. That's based on its intended use. It's based on regional and local code requirements. Where you are, you have enhanced performance requirements in coastal regions. Who's responsible for, in the first instance, determining what the level of performance is required of the building envelope and its constituent parts? Then, who's responsible for selecting the products to meet those requirements? Who's responsible for making sure that the various components are compatible with each other and detailing how they're going to be integrated into the completed envelope system? Paul, we've both seen building envelopes that have combinations of stucco, masonry, brick, metal panels, curtain wall, window wall, sliding door, storefront. Who's responsible for making sure that each of those individual components meet the performance requirements, perform together, and are erected in the right manner?
Lots of opportunities for problems there.
An often overlooked piece of that is the definition of the scopes of work and the sequence. And that's an allocation issue. Is that all going to be specified by the architect? Is the architect going to specify the order in which the various components are installed and who's responsible for flashing in which areas, who's responsible for which caulking, who's responsible for which integration details? Or is it going to leave that for the general contractor to determine in how it breaks up the subcontract packages? And who's going to be responsible for making sure that those sequences are followed and the work is performed in the correct order so that the people responsible for integration can actually do what needs to be done before the successor work comes along?
Yes, doesn't that often or usually come down to how the contractor buys out the project as far as, which subs are doing what?
That's how it's implemented, but it has to be thought given to it up front with not just respect to who's going to give me the best price, but how am I going to actually construct this? And then during the project, there's the management, making sure that the contractors are getting into the work when it becomes accessible to them and performing their work that is predecessor to somebody else's follow-on scope of work. So you don't have somebody coming back trying to put flashing in after the windows have been in.
And on top of that, we've got the natural tension that exists in any project between the scope of work and the budget.
Right. And that is another element of risk allocation. There has to be a proportionality between responsibility and the cost of that responsibility. If an owner is looking to a contractor or an architect is expecting a contractor to take on design risk, then they ought to be paid for that. That's a cost. And, maybe design building envelope is the most cost-effective approach, and maybe it's not. But you have to weigh those things. You have to weigh what's the potential risk, what's the cost of non-performance versus what's the cost of buying that risk or selling it to a particular party, and make an informed decision. The real problems arise when that risk is forced on somebody, when it's done, kind of in a not deceptive, but in a less than clear fashion, and they don't price it into their work. Because if they haven't priced that risk in, chances are they're not going to take the steps necessary to manage it effectively.
Kind of like if you want this job, you've got to meet the budget.
That's always an element. And, the old saying is you can have, fast, cheap, or good, you can have two of the three.
That's right. Well, cheaper is always the one that I see. So what are some of the things that should be taken into consideration when deciding the best way to allocate risk in the design and construction contracts?
So we talked about some of them. Certainly it starts with which of the parties, the designer, the general contractor, the glazing subcontractor, the manufacturing supplier, which one's in the best position to avoid or manage the risk of non-performance. If it's a product manufacturing issue, obviously the manufacturer is in the best position to manage that risk. If it's a installation issue, the installer's in the best position to manage that risk. Where it gets trickier is where things become, at the intersection, product selection, integration of different systems, where you have multiple parties involved and there is a need to coordinate their efforts and to oversee their performance to make sure that each does what is required of them. And that's when you need to look at things like who has the expertise to identify risk, to manage it, to correct it. Obviously, if it's a pure engineering issue, it's the design team that holds that expertise. Who has control and authority? In a typical contracting situation where the owner contracts with the architect and contracts separately with the general contractor, the architect's engineer's ability to manage and control the subcontractor, to hold them to design requirements, is limited. They don't have contracts with those parties, and most importantly, they don't control the purse string. They don't hold the checks. That's the owner or the general contractor. Sometimes there are licensure requirements or certification requirements that dictate where risk has to be allocated. If design drawings have to be signed and stamped, that the professional who signs and stamps them puts his expertise behind that product and warrants that it is accurate and will perform. Product certifications. It's the manufacturer who tests the product and obtains the certification and represents that the product will perform to that certification. And then the last thing we touched on was there's the comparative cost of allocating that risk. If the owner or GC is going to allocate risk to one of the parties with whom it contracts, then the contract price ought to reflect that risk to ensure that the party has the resources and the motivation to manage it.
So what are some best practices with allocating risk between the design and construction contracts as it relates to the building envelope?
First and foremost are clear documents. If the specifications are going to delegate design responsibility to the contractor for an element of the building envelope, the documents need to make that clear. It needs to clearly specify what elements of the design is going to be detailed out or finished by the contractor, so the contractor knows what's expected of it and, again, can price it into its contract. So, the documents need to be clear what's expected, level of detail is in the shop drawings. If there are design detail drawings, what is expected and what standard will be applied. Are coordination drawings required? What are they cover? There's nothing wrong with delegating those elements of design to a contractor, and there's nothing wrong with the contractor assuming those responsibilities. Both parties need to understand what they're requiring and what's expected of them. When there's design delegation, it's still important that the architect engineer be responsible for review and approval. I think that it's also a good idea to contractually require the architect and engineer and the contractor and the appropriate subcontractor or supplier to mutually inspect the work or a mock-up and to accept the implementation of the delegated design into the architectural specification. If you're not, specifically with respect to a building envelope, if I'm advising an owner, one of the things I will suggest for a large construction, particularly one that is intended to have some architectural pizzazz to it, and might have a complicated building envelope. When you're negotiating with the architect or when you're interviewing the architect, I would want to see a demonstrated expertise in building envelope design. And if I'm not comfortable, I would consider contractually requiring the AE to either have a subconsultant building envelope for the building envelope, and obviously that cost gets passed to the owner. The other thing to consider is single source responsibility for the building envelope. Here we're talking about a design build contract for the building envelope itself that has a single source of responsibility for both design and construction, so when things go wrong, it eliminates the typical finger pointing.
So let's shift over to risk management. What are some examples where failure to properly manage the design and construction process can increase the risk of non-performance?
The big one is what I call Frankenstein design or specifications. Got mix and match components or system details that get revised either because the architect has a particular concern from a past project or as part of the value engineering effort. Whenever you are using multiple materials and systems as part of the building envelope, or if you're making revisions to standardized details, it's critically important that you involve both the manufacturer and the installer, and you get their input and approval. There's no surer way for an owner to end up with a lot of finger pointing than when you've got a building envelope that is the product of a whole bunch of value engineering efforts where system components have been changed or revised, and the original manufacturers and suppliers don't take responsibility because it's not the system they tested and warranted.
What are some of the best practices in risk management to avoid or decrease the risk of non-performance?
So again, when we're talking about building envelope systems, particularly those that might integrate various materials or various separate systems from different manufacturing sources, integration and coordination is really the key. And there are a number of collaborative design tools now available to help with that effort. BIM is probably the best known, building information modeling. It allows for integration of shop drawing and product information into the architectural design. Gives a depiction of how a specific product requirements. It'll give you a depiction of the specific performance capabilities of a product in the design drawings. It'll incorporate that information. It will incorporate the shop drawing details into the original design drawings. So everybody has now a set of drawings that have a complete design showing all of the contributions for the building envelope. It will help to detect clashes between those various components at the design stage, so you can work to resolve them. There's submittal management software to help track product submittal, shop drawings, their review, rejection, return, resubmittal, ultimate approval. That becomes very helpful in projects that experience delays, because it's when a project gets delayed and everybody's hustling to try to catch up or to avoid falling further behind that shop drawings don't get submitted, or they get submitted but they get only a cursory review, or they never get resubmitted and nobody follows up. Product information isn't closely evaluated and potential problems aren't detected. Kickoff and coordination meetings, an old-fashioned management tool. Work out all the integration and sequencing issues before the work actually starts. Get everybody on the same page. Mock-ups and field testing of complicated building envelopes are invaluable. Actually build the thing at a smaller scale and test it to make sure that it's going to perform the way it's intended.
Those are many of the things that are near and dear to our hearts at GCI Consultants as we work on projects, showing everything clearly. You used to get these flat details, 2D details for corner conditions where a lot of materials are coming together. And there was a lot of guesswork to try and put it all together and have it work. And then getting everybody together at the beginning of the project, to the beginning of design, also the beginning of construction, to make sure that all the parties know each other's roles and are on the same page and working together, and then doing a mock-up. A lot of times it can just be an in-place mock-up on the building as early as possible and testing it so that if you do have a problem, you identify it and solve it before, a year later, everybody's getting ready to move in and all of a sudden you got to go back and do a remediation program. So Tom, really interesting. And, I think we've still got a lot of things that we could talk about, particularly as it relates to the building envelope and performance and disputes and whatnot. Would you be up to doing a part 2 of this podcast to kind of delve a little deeper?
Sure. Absolutely. Be my pleasure.
Great. Yeah, that'd be wonderful, because I know it's really interesting. It's great stuff. Would like very much to keep charging into or diving deeper into it. So we'll do our next episode will be a continuation of this one. And Tom, again, thank you very much, and really look forward to doing that with you.
Thank you.
So thank you, everyone, for listening to the Everything Building Envelope podcast. I want to remind you again that we have the Everything Building Envelope newsletter. And if you're interested in getting on the list, please text the word building envelope to 22828. Again, building envelope to 22828 to receive the building envelope newsletter. And that ends this episode of the Everything Building Envelope podcast. Thank you for listening. And this is Paul Beers saying so long till next time.
Thanks for joining us today. Please subscribe to this podcast on iTunes or Stitcher. For more information on the Everything Building Envelope, previous episodes, show notes, bonus video content, and much more, check out our website, everythingbuildingenvelope.com.